Have you ever really thought about what's happening behind the scenes every time you buy a coffee or shop online? There's this silent guardian, this invisible piece of technology watching over your wallet, and it works in literal milliseconds. We're going to pull back the curtain on this hidden world of what some people call database reflexes.
Okay, just picture this for a second. It sounds impossible, right? You're standing in one city, but your money is suddenly being used on the other side of the planet. For a thief, that's a jackpot. For you, it's a total nightmare. But for the system that's always watching, it's just another Tuesday.
So what actually happened in that tiny slice of time between the fraudulent swipe and your bank saying, nope, not today? It wasn't magic, and it definitely wasn't luck. It was an incredibly sophisticated system executing a perfect defense. So the real question is, how on earth does it work?
All right, let me introduce you to the hero of our story, the risk engine. The best way to think about it is like a digital detective. It's a super complex database system that doesn't just store information, passively. No, it actively interrogates every single transaction, in real time, looking for anything that seems even a little bit off.
So how does this digital detective make up its mind so fast? Let's actually go inside the engine and take a look at the anatomy of how it thinks.
The core idea is pretty simple. Nothing gets a free pass. Your $5 latte, it gets analyzed. That $100 grocery run, analyzed. That $1,000 plane ticket, you bet. Every single one gets assigned a risk score the instant it happens. The speed and the sheer scale of it all, it's just staggering.
So how does it build this case so quickly? Well, it's looking at a whole bunch of different clues all at once. It's checking things like your location, what you normally spend money on, whether the merchant seems shady, what device you're using, and it's also looking at something called transaction velocity. Basically, it's asking, was this card just used in Charlotte and now, 2 minutes later, it's popping up in Singapore? That's physically impossible. Each of these data points is a tiny clue that helps it paint a full picture and spot the fake.
And this all happens in this lightning-fast 4-step blitz. First, the transaction happens. Instantly, the engine grabs and analyzes all those data points we just talked about. Then, it spits out a risk score, and based on that score, boom, it responds. The whole thing happens faster than you can put your card back in your wallet.
And the system's response isn't always just a hard no. I mean, if the risk score is through the roof, yeah, it'll just block the charge completely. But if it's only kinda suspicious, it might do something else. It could send you that text message you've probably gotten before, right? The one that says, hey, was this you? Or maybe it'll ask for an extra verification code. It's a really smart, nuanced defense system.
Now here's the really crucial part. The system learns. It never stops learning. Every correct block, every false alarm, every time you say, yep, that was me, it all gets logged and fed right back into the AI model. So the risk engine that's protecting you today, it's going to be even smarter and more accurate tomorrow.
But these systems weren't always this intelligent, not by a long shot. They have a really fascinating history, evolving from these really simple, rigid rules to the kind of sophisticated AI we depend on today.
In the early days, fraud detection was based on these very simple black and white rules. Something like, block any foreign transaction over $500. Of course, criminals figured that out super fast and just started making charges for $499. Today's AI is playing a totally different game. It's adaptive, it's fluid, and it can spot these incredibly subtle patterns of a global fraud ring that a simple rule would never, ever catch. This timeline really shows you the incredible acceleration. When e-commerce just exploded, the old ways couldn't keep up. So we went from those brittle, static rules in the 90s to some basic analytics in the 2000s. Then the 2010s brought the machine learning revolution. And now we have advanced AI that's fighting battles we couldn't have even imagined, like detecting synthetic identities. That's where criminals literally invent a fake person by stitching together real and fake info, all to commit fraud. It is a whole new level of cat and mouse.
Now, blocking fraud is obviously job number one, but all of the intelligence that the risk engine gathers has become incredibly valuable in so many other ways. It's about way more than just stopping a single transaction.
The data flowing from these systems is an absolute gold mine. On a huge scale, it's used for crime prevention, helping authorities spot things like money laundering networks. It helps banks with all the strict regulatory stuff they have to do. And it even provides anonymous insights that help businesses improve their services for all of us.
And this is exactly why that term, database reflex, is so perfect. Think about it. It's just like your body's reflex to pull your hand away from a hot stove. The system reacts instantly, automatically, and protectively. It's this built-in, adaptive response to danger that's happening all the time, just beneath the surface of our digital lives.
So what's the scale of this protection we're talking about? Well, it's measured in the billions. Billions of transactions analyzed every single day. Billions of dollars in fraudulent charges blocked every single year. The sheer volume that these systems handle is, well, it's almost impossible to wrap your head around.
And ultimately, this right here gets to the absolute heart of it. This technology does so much more than just stop theft. It generates the trust that we all need to even participate in the digital world. Without it, buying something online would feel incredibly risky. These systems are the very foundation of that trust.
But this evolution never stops. As the bad guys get more sophisticated, even using AI to create new kinds of attacks, our digital defenses have to evolve even faster. So the question we're left with is this: in this ever-expanding digital universe, what's the next great threat our database reflexes will have to learn to fight?